All right, so running through two examples. The first one, 100 kilogram crate is pushed across the floor. Determine the following. What's the minimum force required to start moving the crate if the coefficient of static friction is 0.6? So first thing I'm going to do, free body diagram, very important. So here's my free body diagram. 100 kilogram crate, so that would be force due to gravity. Fg would equal mass times gravity, 100 times 9.81, and we get 981 newtons. So that's our force due to gravity. Now, it doesn't indicate that we're pulling or pushing on any different angle than horizontal. So that would mean my normal force is going to be equal to my gravitational force. So to answer A part then, I know that force due to friction is equal to mu multiplied by the normal. So in this case, it's given mu static is 0.6. My normal force is the 981. And calculating that, 0.6 times 981, we get 588.6. So what is the force required? Therefore, you need to apply a force greater than 588.6. Okay, very careful with the wording here. All right, because if it's equal, if you only push with 588.6, you're not going to move it. Okay, that's the frictional force. If forces are equal, no motion occurs. It would keep in its current state. So you need to make sure you need to add the word more or greater into your therefore statement. B part then, what is the minimum force required to continue moving the crate once it's in motion if the coefficient of kinetic friction is 0.4? Same formula, the difference is now we're using mu k in the formula instead of mu s. So 0.4 multiplied by the 981, and we get 0.4 times 981, 392.4 newtons. That'll be opposing motion, so I'll put that to the left. That should also be to the left. So 392.4. If I want to maintain that motion, I have to apply that exact force. So therefore, you must apply 392.4 newtons to the right to maintain motion, so there's no acceleration. Okay? Now, what's the applied force required to accelerate the crate at 2 meters per second? 2 meters per second squared. So if acceleration is 2 meters per second squared, then force unbalanced will equal mass times acceleration. We know the mass of the object was 100 kilograms. We know the acceleration is 2. So we need an unbalanced force of 200 newtons to the right. Now the object is, we're going to, I guess, assume in motion. So therefore, if in motion, the applied force must be 200 newtons. So that's how much is needed to accelerate the object, plus you have to overcome friction, so 392.4, to get a grand total of 592 newton, 92.4 newtons to the right. Okay, so this is to accelerate, and this is to overcome friction. So you got to remember both components when they were looking for a final applied force. Okay, so it needs 592.4 newtons to overcome friction, and then the 200 newtons left over will do the accelerating. All right, final example. If you pull a 50 kilogram wagon with the handle at an angle of 30 degrees and an applied force along the handle of 350, that should be newtons. Determine the coefficient of friction to ensure no acceleration. So here's our wagon. What do we know? I know that I have a force due to gravity here. So force due to gravity will equal mass times gravity. 50 kilogram wagon times 9.81. Do the calculation there. 50 times the 9.81. We get 490.5 newtons. Now, there's an applied force, I'm going to do this in red, of 350 newtons. And that's at 30 degrees. So now you have to bring out your components to figure out FAX and FAY. All right, so FAX, if you go back to your vector formula, you know that it's the magnitude of the force cos theta, which would mean 350 cos 30 will tell me the x component. So 350 times 30 cos is 303 newtons, we'll call it. So even though you're pulling with 350, only 303 newtons are actually in the useful direction. Next, we'll find FAY. So FAY is going to equal magnitude of the force, so it's your y component. So it'll be sine theta. So 350 sine 30. Punching that through the calculator, I get 175. All right, and I guess that's to the right, that's up. So if I come back over here then, therefore, my normal force in this case is equal to force due to gravity minus FAY because it's pulling it upward. So my normal force is in the same direction as FAY, so it's helping me out here. So that means that it would be 400, force due to gravity is 490.5 minus 175, which gives us 315.5 newtons up for the normal force. So force due to friction is what I need here. So I'm looking for my force due to friction, and I have to use that normal that was just calculated. So the force due to friction would be multiplied by my normal. So I want to ensure that there's no acceleration. So what I need to do is I need to figure out what my mu is going to be. So force due to friction is going to be equal to my normal force multiplied by mu, which I don't know. Mu multiplied by 315.5. So how do I find mu? Off to the side here, I'm going to just do a note for you when you look back in this. If acceleration is equal to 0, then force due to friction must equal, and force due to friction will equal the applied force. Okay, so therefore, our force due to friction for this question would have to be the 303 newtons. All right, force unbalanced, remember, is the applied force minus force due to friction. Maybe that form also helps you out. But if it's equal to 0, that means that the two would have to be equal to each other. So coming back to my problem then, 303 is equal to mu 315.5. So now just using your math skills to find that division, we find that mu is going to equal 0.96. So basically this wagon is in boulders with flat tires because mu of 0.96 is very high. So therefore mu would be 0.96, very bad conditions. Because it's so high, I would say you definitely have flat tires and probably pulling it over very treacherous terrain if that's the case. So there we are. So the homework's here, page 183, 39 to 50. That will give you a feel for sort of combining a lot of things together that we've already talked about. Um, and the previous example and this example should definitely be able to guide you through a lot of the questions. So if you have any problems in class, let me know, and I will give you a hand in getting through them.